Hi guys, welcome back to a case of econ struggles. Today we're talking about elasticity, what it is, why it's useful, how to calculate it, and how to interpret it. Timestamps are below if you would like to jump around, but let's start talking about what elasticity is. In order to better explain what elasticity is, I'm going to use an example. So I'm going to use the price elasticity of demand. So the price elasticity of demand is the percent change in quantity demanded when the price changes by 1%. So when we talk about elasticity, what we're trying to get at is how sensitive quantity is to a change in price, generally formed as a percentage. Now, why are we worried about this whole percentage elasticity thing? Why can't we just take the slope of the demand curve? Elasticity is not equal to the slope of demand. So you can see here in this example, my demand curve is curved. So the slope along this curve is not constant at all points on this curve. So elasticity is not equal to the slope of demand, and that's something really important to keep in mind. Another reason that elasticity is useful is because pack size doesn't matter. What in the world do I mean that pack size doesn't matter? Well, here's an example. Suppose you have two stores. You have a store that sells Gatorade by the bottle, so just a single bottle of Gatorade. You have other stores that sell a 12-pack. If you have two demand curves, this is for single Gatorades and this is for 12 packs, which slope do you use to calculate how sensitive quantity of Gatorade demanded is to price? Where this price is for a single Gatorade, this price is for a 12-pack. So maybe this price is a little lower. Maybe this demand curve has a different slope than the demand curve for a single Gatorade. So which one do you use? Well, if you use elasticity, it's a percentage change, and so pack size won't matter. Now let's talk about calculating elasticity using something called the midpoint formula. There are different ways to calculate elasticity. So if you're Googling, you might see some ways that use derivatives, but this is not a method that uses derivatives. So the price elasticity of demand is calculated as the percentage change in quantity over the percentage change in price. So you can just take two different points, calculate their percentage change in this fashion, and calculate the change in price in a similar fashion, divide them, and you're going to get an elasticity. That's sort of abstract, so here's a better picture of that, where I pick 2 points on the demand curve that I'm trying to calculate the elasticity for. So here's this first point, it's got a price and a quantity in green. The second point is a price and quantity in blue. And you can see that I've taken that same formula that we saw earlier and just plugged in those 2 points so that it's easier to see how we calculate this elasticity. All right, so now you've calculated an elasticity and you're trying to interpret it. The way we interpret elasticity is based on a scale, and we are going to talk about the absolute value of the elasticity that we calculated before. Why are we using the absolute value? Well, when we talk about demand, we tend to think that quantity goes down as price goes up. But if we're talking about some other elasticity, like elasticity of supply, we might think that supply goes up as the price of that good goes up. So if we take this absolute value and we think about elasticity in absolute value terms, it's going to be easier to interpret across different types of elasticities. So let's go through the categories. If I get an elasticity of 0, that means I'm perfectly inelastic, which means that as the price changes, I don't change the quantity I demand at all. If I'm inelastic, that means that my change in quantity percent-wise is less than my percentage change in price. If I get an elasticity value of 1, we call that unit elastic, so my change in price is exactly equal to my percentage change in quantity. Anything above 1, we're calling that elastic. That percentage change in quantity is greater than the percentage change in price. And if I get an elasticity value that approaches infinity, we call that perfectly elastic. That means that a tiny percentage change in the price leads to a ginormous percentage change in quantity. That is the table I like to use to reference in terms of interpreting elasticity. I've also drawn some graphs to hopefully make it a little easier to see. So here's perfectly elastic. This demand curve has a slope of 0 all the way through. So here we can use the slope, but again, this is a very special case. In general, you should not assume that the slope of the demand curve is equal to elasticity. If I have a perfectly inelastic demand curve, it is a vertical line, so the slope is infinity. If I'm elastic, then my slope is flatter than -1 if I'm talking about the price elasticity of demand. So notice price goes down and quantity changes a lot. If I'm inelastic, my slope is pretty steep. So here with the price elasticity of demand, my slope is steeper than -1. Notice that that means here price changes a lot, but my quantity doesn't really change. So again, my percentage change in quantity is less than the percentage change in price. Over here, when I'm elastic, my percentage change in quantity is greater than my percentage change in price. And if I'm unit elastic, my slope is exactly 1. The percentage change in price is exactly equal to the percentage change in quantity. Like I said, we'll get into the different types of elasticities in a different video, but hopefully this gives you a better idea of what elasticity is, how to calculate it, and how to interpret it. If it did, make sure to like and subscribe, and we'll see you next time for another case of econ struggles.